Okay, the first thing is when introducing 10, you want to start introducing 10 with the 10 frame. And so up to this point, your children would have had experience with the 5 frame. So just explain to them what is a 10 frame made up of. It's made up of a 5 frame on the top and a 5 frame on the bottom, and two 5 frames will make a 10 frame. So the introduction of it is pretty simple. Remember, if you can get 2 color counters, that's something that you'll want to use. And remember, you can make more numbers than just 10 on a 10 frame. You could make 8 or 7 or 6. But just for this demo, we will focus on 10, and that's where you're going to want to spend most of your time when you're working on 10. So for example, right here, we could go ahead and say, okay, remember, work left to right, no polka dot counters. And how was 10 made here? And we know that 10 was made with 8 yellow and 2 red. And remember, when you say make 10 a different way, you don't want them to make 10 a different way by clearing their card. You just want them to go ahead and go, okay, let's take a look here. So we had 8 and 2, now we have 7 and 3. Now we have 6 and 4, and then you can go ahead and you can flip it over too for the commutative property, where you can show them that 6 and 4 and 4 and 6 will equal the same thing. Remember, this is a concrete exposure that they just had. Okay. Another concrete exposure that you can use is, if you remember this from the 5 frame, again, two sets of 5 unifix cubes to make 10, and this is what you can do too. And remember, it's important that it's 2 different colors. If it's 10, if I do something like this and I break it off, we immediately know there's 5 there, and then one more would be 6. If they're all the same color, no matter how skilled a child is or even an adult, they will have to end up counting. So you just want to keep that base there. So remember, for when you have this, you can go ahead and say, all right, make and break it. They just randomly break it. And right now we have 3 and 7 is our combination of 10. Say, all right, ready? Break it again, and it could be 2 and 8 or 8 and 2. All right, and another exposure that your students can have, and remember, the idea of all these of seeing it in many different ways is called, there's a lot of research on multiple representation. And all that means is that the more times a child sees something in a particular way, the more in depth, the stronger background and foundation that they'll have on it. So again, if you are making a 10 like this, we could say, okay, this is a 10 rack. Remember, they have to understand there's 10, and this seems like an easy transition. And a lot of kids, you're like, okay, there's 10 on here. And then you'll do something like this, and you'll say, okay, how many on here now? And they'll go through 1, 2, 3, 4, 5. So they have to understand that there's always going to be 10. There's no way that you cannot have 10 on this, okay? And so ways you can do is you can go ahead and chunk it like this and say, all right, what do we have here? We have 8 and 2, and then you can flip it over, and now you can say, oh, we have 2 and 8. And this is called a 10 rack, all right? Okay, and another exposure that, remember, this was a concrete exposure, and now we're going to look at how we can scaffold this. Just like we did with the 5, you can go ahead and, remember, this is called hide and peek. You can go ahead and break some off and say, all right, if I have 7 here, how many have to be in my hand then? So we know the whole was 10. We were giving them the part, which would be 7. And that's another exposure that you can do. And then finally, going back to the 10 rack, we've used the 10 rack. You can go ahead and say, all right, if there's 6 here, how many be under here? Remember, the idea is that they know if there's one thing that they get from this, it's knowing those combinations of 10. That is the most important thing that they can learn. Because you'll see when we go to 20 and when we go to 100 and even working on 1,000, why it's so important that they have that, they know those combinations of 10, because it's a foundational skill and it expands. It acts as that. All right. Now again, you can go ahead and you can do 10 frame flashes with your kids too. This isn't necessarily subitizing, it's more of a conceptual subitizing type thing, but you want them to use the base of the 10 frame. So you could go ahead and something like this. How many were there? And they would say 6. The important question that their follow-up should be, if there's 6 there, how many more would I need to make 10? And the answer would be 4. And then you can go ahead and do things like this. Again, the screened array right there. So we have 7. If there's 7 there, how many would be under here? And again, there's 7. And we know that it would be 3. Now there's 3 there. And then you'll realize kids are really good at learning, 9 and 1, 8 and 2, 7 and 3. But where they struggle is when they're fronted with the smaller of the numbers. So if you give them 8, most kids very easily be able to do 2, right? But they should know it like the back of their hand. So whether they're fronted with 8 or 2, they still should know the answer. So again, if this is 2, what's all of this right here? This would have to be 8. And so showing it that way as well. And then a transition to go is, up to this point we've worked with all manipulatives. Now what we're using are these. You may have seen something like this before, but it's not proportionate. It'll have like a 10 and it'll cut it exactly in the middle. So what this does, it also, if you think about fractions, right? Like if this was 10, this is what 3 would look like, right? We wouldn't cut it in half, say this is 3, what is that? So it shows a proportionate rate as well. So if we're taking a look here, we have 10. If this is 3, what goes with 3 to make 10? And we know that the answer to that would be 7. And then right here we have 10, and 10 is our whole. We have 8, then what does this part have to be? This part has to be 2. So if you take a look, we went from starting off very concrete, now we're almost working completely in the abstract. Okay, and the last thing that we'll do is we're gonna go ahead, remember we start off, we worked very concrete, right? We worked with unifix cubes, and we worked with 10 frames, and we worked with 10 racks. And then what we did is we slowly transitioned these into more abstract, where there was still some concrete, but we scaffolded, and then we started doing that algebraic thinking with it. So the last thing that we are gonna do now is we're gonna work just purely with the digits, okay? And these are called 10 puzzles, okay? And it's exactly what it is. So if you have 7, there's a puzzle piece here, and it would be 3. This is something you could set up, as like a center where kids have to go ahead and put the puzzle pieces together. Or you could pass these out to your students and say, okay, if 7, 3, go find your puzzle piece, put it together, and you're going to make that 10. So we have 7 and 3. We have 2 and 8. We have 6 and 4, and finally the last one would be 9 and 1. And so a lot of times when we are working on teaching or making 10, we focus on just the digit part, right? Have students memorize these digits and then they'll know how to make 10. But you want it to be like a natural thing where they have so many different exposures that when they see 7, they know 3. When they see 2, they know 8. Instead of memorizing it, you want them to have that foundation, that flexibility with what they're working on.